Hello everyone, welcome back to my videos. This time we'll talk about the Natural Language Processing Project with the title of Research Paper Summarization Engine by me, Hardeva Ragonando. Let's get right to it. Alright, what we're going to talk about right now is the first one is Summarization Engine, about what is a summarization engine, and the second one is the about T5 small and Pegasus models, where we're going to talk about how T5 small and Pegasus models really works. And the number three is implementation and experimentations, where we talk about applicating the T5 and Pegasus models for summarizations. And the number four is conclusions and future works, where we talk about summary and enhancement plans. Let's get right to it. The number one is the summarization engine. What is a summarization engine? Well, Summarization Engine is a deep learning application designed to automatically transform long pieces of text into shorter versions that retain the most critical information. It leverages algorithms that can analyze content, understand context, and generate concise summaries. This tool aids in efficiently sifting through large volumes of data, making it important for professionals across various sectors who require rapid processing of information. Well, there are two types of summarization engines. The first one is the extractive, where it operates by identifying key phrases or sentences within the original text and stitching them together to form a cohesive summary. It's akin to highlighting the most significant parts of a document. This method ensures that the summarized content is directly grounded in the source material. And the second one is the abstractive, where it goes a step further by interpreting the meaning of the context and generating entirely new sentences. It mimics human-like summarizations, crafting novel phrases, expressions that captures the essence of the original content, but in a new and often concise form. Well, it's about the number two, where we talk about the T5 small and Pegasus models. Well, before we go into that, we have to know what is Hugging Face. Well, Hugging Face is a technology company specializing in artificial intelligence and natural language processing, or NLP, technologies, widely recognized for its open source contributions and development of the Transformers library. This platform facilitates the creation, training, and deployment of state-of-the-art machine learning models, particularly in the domain of language understanding and generations. With a strong community focus, Hugging Face supports researchers, developers, and businesses in, in advancing and applying AI innovations across various applications, making cutting-edge technology more accessible and collaborative. Well, let's talk about T5, or text-to-text transformer, hence the name T5. T5 process all NLP tasks by transforming input text into output text, regardless of task type. A single model, loss function, and set of hyperparameters are utilized for diverse tasks, streamlining NLP workflow. The model is pre-trained on a large corpus to predict mass spans of text, aiding in general language understanding. Fine-tuning is tailored in task-specific prompts, adapting the pre-trained model to specialized tasks. The diagram above presents the T5's capability to adapt to various NLP tasks using a consistent text-to-text method, highlighting its versatile and unified approach. And the next one is the Pegasus, or the pre-training with extracted gap sentences for abstractive summarizations, where Pegasus utilizes gap sentences as the pre-training objective, a novel approach that masks important sentences from input text and trains the model to generate them as a summary. The architecture compromises a transformer encoder to process the input text with mask tokens and a transformer decoder to generate the target text. While Pegasus also trained on a large corpus, or C4, to understand a wide range of topics, which is crucial for summarization tasks that requires broad knowledge. The diagram illustrates that Pegasus model's unique self-supervised learning strategy that makes that masks and predicts the entire sentences, simulating summary generation. The diagram above also depicts that the Pegasus model's flow, where selected sentence from the input text are masked and model learns to predict these gaps, effectively teaching it to summarize. This method allows Pegasus to learn from which part of a text are most salient for a summary, closely mimicking how human might approach summarization. The number three is our implementation and experimentations, where we finally applicating the T5 and Pegasus models for summarization. Before we go straight to our models, let's take a look at our dataset. The dataset informations where we use SciTLDR is a new multi-target dataset of 5.4K TLDRs over 3.2K papers. SciTLDRs contain both author-written and expert-derived TLDRs, where the latter are collected using a novel annotations protocol that produce high quality of summaries while minimizing annotation burden. And these are exploratory data analysis where will use two formula, namely flash kinchite grade level and gunning fog index. And the first one we are going to talk about is the word cloud insights. The word cloud displays predominant terminology from the training set scientific abstracts, providing a visual representation of frequently occurring keywords or subjects. And the second one is the consistent complexity. From the table on the right, yeah, on my right or your left, the table indicates that our summarization maintains the original abstract's informational depth, meaning the flash by using the flash kinchite and gunning fox score, showing that the summaries retain the level of complexity comparable to the source text. As you can see from the table, there are the data frame of train and test and the validations, and the value of the average flash kinchite grade and the average gunning fog index will still retain the same between the train, test, and validation. Well, this is one of the metrics that we will use, ROGUE, recall oriented understudy for casting evaluations. Well, it's a set of metrics designed to evaluate automatic summarization of text as well as machine translations. It works by comparing an automatically produced summary or translation against a set of reference summary, typically human generated. Rogue One, it measures the extractive quality of the content. Well, we'll talk about it later down the line. Rogue 2, it helps to capture phrases and sentence level fluency. And Rogue L, it reflects the summary structure by identifying the longest co-occurring in sentence word. And a Rogue L sum, it measures the longest common subsequence, taking into account sentence level structures and considers sentence boundaries. Well, what's the formula to count all of this? It's this. Rogue One is we got Rogue One from the number of overlapping unigram between summary and reference summaries divided by the number of unigram in reference summaries. While Rogue Two, we get Rogue Two by the number of overlapping bigram between summary and reference summary divided by the number of bigram in reference summary. Well, you get the point. Like in Rogue One, we use the unigram, and Rogue Two, we use the bigram. And the rock L, we got it by the length by dividing the length of the longest common subsequence divided by the length of the reference summary. While the rock L sum is the sigma or the sum of length of the longest common subsequence divided by the length of the reference summary. Well, here are our model performance. Uh, this slide compares the performance of two summarization models, Pegasus and T5 Smalls, using training and test loss as well as rogue scores. T5 Small was trained for 10 epochs, with each epoch taking approximately 20 minutes, allowing for a more extensive period. On the other hand, Pegasus training was limited to 3 epochs due to the higher computational demands, with each epoch lasting about 3 hours. Therefore, we can afford for more epochs to train the Pegasus model. Despite fewer epochs, Pegasus likely outperformed T5 both loss and rogue scores, indicating a more efficient learning process. And T5 final training loss was higher, a little bit higher, 0.036 compared to Pegasus at 0.041, while test loss for T5 were considerably higher at 0.696 than Pegasus at 0.607, suggesting that Pegasus was less prone to overfitting. The rogue scores comparison across datasets shows Pegasus summaries are closer to the reference summaries than those of the T5, particularly in terms of overlap and order of phrases or rogue L. As we can see from the graph over there, we can see that at the rogue L, the Pegasus one is not differ too much rather than the Rogue L from the T5 small, meaning that the uh, summaries generated from the Pegasus are quite similar to the summaries that human generated rather than the T5 small generated. Let's see how our model works. Well, this is our front end of the research paper summarization engine, where if we put nothing there, it'll yeah, we use our own my own paper over there, and let's click summary. The model will generate our research paper summary. It's my own paper, by the way. Yeah, it's about my first paper. It's about there, as you can read it by yourself there. And let's use our second paper. Yeah, it's also my own second paper. It's from my bachelor thesis. Let's try to summarize it too. The model is still running. It's about, yeah, it's simulation and implementation of a artificial intelligence in drone. Yeah, and this model finally generates the summary over there. Okay, let's continue. And this is the last part of our presentations, the conclusions and future works. Where the conclusion is we implemented the five small and Pegasus models in summarization engine, focusing on scientific documentation summarization using the SHI TLDR dataset. Uh, The Pegasus model was selected as the final choice due to its superior performance in rogue scores and training or testing loss metrics. Due to the limited computational resources, no fine-tuning was performed on the models, prioritizing a direct implementation approach. Develop an end-to-end solutions with fast API and Streamlit and containerize them with Docker, enhancing user interactions and accessibility. And about the future works, well, the number one is that we can explore advanced model like T5 large or GPT-3 for improved summarization quality. And we can incorporate diverse datasets to enhance engine's versatility. And we can also conduct in-depth model fine-tuning with increased computational resources. And we can also apply the summarization engine across different fields, maybe like legal or educational. We can also integrate user feedback for continuous model improvement. We can also finally expand capabilities to include multilingual summarization for global accessibility. Thank you. If you have any questions, feel free to ask me. And here's I give you the GitHub link project, GitHub project link. All right. See you in the next video. Bye bye.